November 2nd, 1942. Bath Iron Works, Maine. The USS Nicholas, Fletcher-class destroyer hull 449, slides into the Kennebec River just 8 months and 29 days after her keel was laid. For a warship of this size and complexity, the speed is extraordinary. Traditional destroyer construction demanded 18 months, sometimes 2 full years from steel cutting to commissioning. Yet here stands proof that American shipyards had discovered something the naval establishment insisted was impossible. Preparing and narrating this type of story took us long efforts and hard work. So, if you are enjoying the story, please consider subscribing to our channel. The Nicholas represents more than rapid construction. She embodies a revolution in how warships are built, a transformation driven not by admirals or engineers in Washington, but by welders on graveyard shifts who understood steel in ways that blueprints never captured. Among them, women who 6 months earlier had never held a torch, now fusing destroyer hulls with precision that would carry men through the most brutal naval war in history. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Picture Bath, Maine in early 1942, a river town of 20,000 souls, suddenly swelling to accommodate an industrial transformation that would reshape American naval power. The Kennebec River, which had launched wooden sailing ships since 1743, now thundered with the sound of arc welders and pneumatic hammers. Bath Iron Works, a shipyard that had built exactly 8 destroyers between the 2 world wars, was about to produce more destroyers than the entire Imperial Japanese Navy would construct during the conflict. The mathematics were stark and unforgiving. On December 7, 1941, the United States Navy possessed 166 destroyers. Many were obsolete 4-stackers from the First World War. The newest, the Benson and Gleaves classes, required 9 to 12 months to build using traditional riveted construction. Meanwhile, Japanese naval power dominated the Pacific with modern, heavily armed destroyers that had been refined over a decade of design evolution. American naval planners faced an impossible equation. To fight a 2-ocean war, protect convoy routes from German U-boats, and challenge Japanese naval supremacy in the Pacific, the Navy needed hundreds of new destroyers. At conventional construction rates, the war would end before sufficient hulls could reach the fleet. Traditional shipbuilding methods, refined over centuries, simply could not produce warships fast enough to replace losses and expand the fleet. The Fletcher-class destroyer represented the Navy's answer to this crisis. Designed in 1939, before war's outbreak, the Fletcher incorporated lessons from a decade of destroyer evolution while breaking free from treaty limitations that had constrained previous designs. At 2,050 tons standard displacement, these ships dwarfed their predecessors. 5 dual-purpose 5-inch guns, 10 torpedo tubes, depth charges, and increasingly powerful anti-aircraft armament made them formidable combatants. But size and capability meant nothing if they couldn't be built quickly enough to matter. The first Fletcher-class keel, USS Fletcher herself, was laid at Federal Shipbuilding in Kearney, New Jersey on October 4, 1941, 2 months before Pearl Harbor thrust America into war. Her completion on June 30, 1942, established a benchmark of 8 months and 26 days from keel laying to commissioning. It was fast by peacetime standards. It was nowhere near fast enough for total war. Bath Iron Works had built its reputation on quality, not speed. Bath built is best built was more than a slogan. It was a promise, etched into every rivet, every weld, every carefully fitted plate. During the First World War, Bath had produced destroyers that earned the Navy's respect for toughness and reliability. But that craftsmanship demanded time, and time was the one commodity America could not afford. The transformation began not in engineering offices, but on the shop floor. By spring of 1942, Bath Iron Works employed 12,000 workers, nearly 2,000 of them women who had answered the call when men departed for military service. These women weren't simply filling gaps in the workforce. They were redefining what was possible in heavy industrial construction. Jean Croteau was 18 years old when she walked through the gates of Bath Iron Works in 1943. She had no prior welding experience, no industrial training, no engineering background. What she possessed was necessity. The nation needed destroyers. The shipyard needed welders. Jean needed work that mattered. Her training was brutally direct. Experienced welders demonstrated techniques on incomplete ship decks, showing newcomers how to strike an arc, maintain proper angle, control the molten pool. There were no classrooms, no lengthy apprenticeships. Women learned by doing, practicing on scrap steel until their hands steadied and their eyes adapted to the blinding glare of the arc. The men were not universally welcoming. Centuries of maritime tradition held that shipbuilding was men's work, requiring strength and stamina that women supposedly lacked. Supervisors made comments about women jumping back from welding sparks. Male workers questioned whether women could maintain the pace and precision that destroyer construction demanded. Jean Croteau learned quickly to aim her sparks at supervisors who mocked her, watching them jump back just as she had. But more importantly, she learned steel, how it behaved under heat, how different positions required different rod angles, how the sound of a coned, good weld differed from a poor one. How to read the color of the molten pool to judge temperature and penetration. This knowledge, multiplied across thousands of women welders, became America's secret weapon in the Industrial War. The revolution in destroyer construction rested on a deceptively simple innovation borrowed from automobile manufacturing: modular assembly. Traditional shipbuilding proceeded linearly. Keel plates were laid, frames were erected, plates were fitted and riveted in sequence from bottom to top, stern to bow. Each step waited for the previous one to complete. Skilled craftsmen worked in cramped spaces, fitting complex systems into finished hulls. Bath Iron Works reimagined the entire process. Instead of building destroyers vertically on the ways, they constructed ships horizontally in sections. Massive pre-fabricated modules, each weighing up to 220 tons, were built simultaneously in covered assembly buildings. While one team erected frames and fitted hull plates, another installed electrical systems in a different module. Plumbers ran pipes, electricians pulled cable, ventilation systems were tested. All of this happened indoors, under controlled conditions, before the modules ever touched the building ways. The transformation was profound. In traditional construction, electricians waited for hull completion before accessing spaces to run cable. In modular construction, electrical work proceeded simultaneously with hull fabrication. When a module rolled out of the assembly building, 70% of its internal systems were already installed and tested. But modular construction created a new challenge that threatened to undermine the entire program: welding those massive sections together without introducing catastrophic weaknesses. Riveted construction had dominated shipbuilding for good reason. Overlapping plates joined by mechanical fasteners created natural barriers to crack propagation. When a rivet hole developed a crack, it stopped at the next rivet or plate edge. Ships could absorb tremendous damage and remain seaworthy because failures stayed localized. Welding eliminated those natural crack arresters. A continuous welded seam created one unbroken metal path from bow to stern. If a crack initiated and propagated through a weld, nothing would stop it except another physical barrier. The potential for catastrophic failure was real and terrifying. Liberty ships had already begun demonstrating this danger. As these welded cargo vessels entered service in early 1942, reports filtered back of mysterious structural failures: ships cracking in calm seas, hulls splitting at the waterline, some vessels breaking completely in two without warning. The crisis would eventually force a comprehensive investigation, but in 1942, as destroyer production accelerated, the full scope of welding's dangers remained hidden. Bath Iron Works welders worked with an urgency born of awareness that their work would carry men into combat. Every bead had to be perfect, every fusion complete, every heat-affected zone properly treated. The margin for error was measured in thousandths of an inch and translated directly into sailor survival. Female welders faced additional pressure. Male workers watched for mistakes that would confirm their prejudices. Supervisors scrutinized women's work more closely than men's. The women understood that their performance would determine whether other women received opportunities. They weren't just welding destroyers. They were proving capability in the face of institutional doubt. The technical challenges of destroyer welding exceeded anything in Liberty ship construction. Cargo vessels were essentially floating boxes, simple hull shapes, relatively uniform plating, minimal structural complexity. Destroyers were different. Curved surfaces met at complex angles. Multiple deck levels created intricate load paths. Weapon mounts concentrated, enormous stresses. Propulsion systems demanded precise alignment. Welding these structures required understanding not just how to fuse metal, but how stress flowed through the hull under combat conditions. Bath Iron Works developed welding sequences through trial and experimentation. Unlike the documented problems with Liberty ships, destroyer welding procedures evolved through careful observation of what worked. Welders noticed that certain sequences produced flatter, more stable joints. Starting welds at module centers and working outward minimized distortion. Alternating between opposite sides of a seam prevented the build-up of residual stress. Breaking long seams into shorter segments allowed controlled cooling. These weren't engineering innovations documented in technical journals. They were practical wisdom developed by people who worked with steel daily and noticed patterns that blueprints missed. Jean Croteau and thousands like her became empirical metallurgists, conducting experiments measured not in laboratory instruments but in whether the joints they created remained sound under load. The pace was relentless. By mid-1943, Bath Iron Works was laying keels for new Fletcher-class destroyers every few weeks. Multiple hulls occupied the building ways simultaneously. Assembly buildings operated around the clock, their interiors blazing with hundreds of welding arcs as modules took shape. The river town that had launched perhaps 4 ships annually before the war now aimed to complete more than a destroyer per month. 11 shipyards across America built Fletcher-class destroyers: Bath Iron Works, Federal Shipbuilding, Seattle-Tacoma, Consolidated Steel, Gulf Shipbuilding, Boston Navy Yard, Charleston Navy Yard, Puget Sound, Mare Island. Each yard developed its own techniques, refined its own procedures, discovered its own solutions to the challenges of rapid warship construction. The competition among yards was fierce but productive. When one yard achieved a faster build time, others studied their methods and adapted useful innovations. When problems emerged, yards shared solutions. The goal wasn't individual glory but collective output. America needed destroyers. The shipyards would provide them. By autumn 1943, the system had achieved remarkable efficiency. Average time from keel laying to launch dropped to 7 months. From launch to commissioning required another 5 months for outfitting, testing, and crew training. Total time from keel to commission averaged 12 months, slashing nearly half the time traditional methods required. But averages concealed the true transformation. The fastest destroyers built during the war broke every pre-war assumption about what was possible. Bath Iron Works, drawing on its growing expertise and an increasingly skilled workforce, began launching destroyers in times that would have seemed impossible just 2 years earlier. The USS Cogswell, hull number 551, slid down Bath's ways on June 5, 1943. Keel to launch, 5 months, 14 days. The USS Caperton, hull 559, followed on July 24. Keel to launch, 5 months, 3 days. These weren't experimental prototypes or simplified designs. They were fully capable Fletcher-class destroyers, ready for outfitting with the complex systems that would make them combat-ready. The women welders at Bath Iron Works stood on those launching platforms, watching hulls they had built slide into the Kennebec River. Jean Croteau remembered standing next to a completed destroyer for the first time, awed by the scale. She said she felt like an ant next to one, her daughter later recalled. The ship Jean had helped build would carry 329 men into the Pacific, where the naval war raged with a ferocity that demanded every destroyer America could produce. The reality of what Bath Iron Works had achieved became undeniable as hull after hull entered service through 1943 and into 1944. The pace wasn't just sustained, it accelerated. What had seemed impossible in 1941 was now routine. The shipyard that naval traditionalists had doubted could match established East Coast yards was outbuilding them all. The numbers told a story of industrial transformation. Between December 7, 1941 and September 2, 1945, 45 months of war, Bath Iron Works delivered 65 destroyers to the United States Navy. That averaged more than one destroyer every 3 weeks, a production rate that exceeded the entire Imperial Japanese destroyer output during the same period. But statistics alone couldn't capture the human dimension of this achievement. Every destroyer represented millions of individual welds, each one placed by hands that had learned their craft under wartime urgency. The women who had entered Bath Iron Works in 1942 and 1943 as novices had become master welders, their skills refined through repetition, and their understanding of steel deepened through constant problem-solving. The welding challenges specific to destroyers went far beyond anything civilian construction demanded. A destroyer hull endured forces that would tear apart buildings or bridges. The propulsion system generated 60,000 shaft horsepower, driving twin screws that pushed the ship to 37 knots. That power transmitted through the hull as vibration, cyclical stress that tested every weld, every joint, every connection. Gun mounts concentrated enormous loads. When a 5-inch gun fired, recoil forces slammed backward with tremendous energy. The hull had to absorb and distribute these shocks without fracturing. Welders working on gun deck reinforcements understood that their beads would face loading that peaked in milliseconds and repeated thousands of times during a ship's service. Depth charge racks presented their own challenges. These stern-mounted systems released 300-pound cylinders of high explosive that detonated underwater near the ship. The resulting shock waves transmitted through the water and hammered the hull. Welders, reinforcing the fantail, knew their work would be tested by friendly explosions as well as enemy action. The cold reality of naval combat added another dimension to welding quality. Destroyers fought at close range, within gun range of enemy warships and vulnerable to torpedo attack. When Japanese Long Lance torpedoes struck Fletcher-class destroyers, and they did, repeatedly the hull's ability to contain damage often determined whether the ship survived or sank. Bath-built destroyers developed a reputation for toughness that transcended marketing slogans. USS O'Bannon, launched from Bath on February 19, 1942, survived multiple kamikaze near misses, typhoons, and prolonged combat operations that would have finished lesser ships. USS Nicholas, the ship that had demonstrated Bath's rapid construction in November 1942, fought through the entire Solomon Islands campaign, the Philippines' liberation, and was still operational when Japan surrendered. These ships validated every weld that women like Jean Croteau had placed. The 18-year-old, who had been afraid of welding sparks in 1943, had helped build machines that absorbed punishment beyond anything peacetime design standards anticipated. Her work, and that of thousands like her, proved that skill mattered more than tradition, that capability transcended gender, and that necessity could accelerate learning in ways that peacetime never allowed. The technical evolution of destroyer welding procedures at Bath Iron Works reflected continuous improvement driven by practical experience. Early in the program, welders followed standard sequences developed for simpler structures. As hulls entered service and feedback returned from the fleet, patterns emerged about which areas experienced the most stress and where cracks occasionally initiated. Bath's engineering staff worked directly with shop floor welders to refine procedures. Unlike the rigid hierarchies that characterized peacetime construction, wartime urgency broke down barriers between designers and fabricators. An experienced welder, who noticed that a particular joint configuration consistently produced problems, could walk directly to the engineering office and demonstrate the issue. Changes to welding sequences or structural details could be implemented within days, rather than waiting for formal design reviews. This collaborative approach produced innovations that formal research might have missed. Welders discovered that certain backing techniques prevented incomplete penetration in difficult-to-access joints. They found that specific preheat temperatures minimized distortion in heavy plate sections. They developed inspection methods that caught defects before they propagated into serious problems. Preparing and narrating this type of story took us long efforts and hard work. So, if you are enjoying the story, please consider subscribing to our channel. The women welders brought perspectives that male-dominated crews had often overlooked. Working in confined spaces, they noticed that certain joint designs were nearly impossible to weld properly because access angles prevented proper rod positioning. Their feedback led to modifications that made critical joints more accessible, improving quality while reducing the time required to complete difficult welds. Jean Croteau's supervisor, who had initially teased her about jumping from sparks, eventually acknowledged that she and other women welders had become among the yard's most reliable workers. Their welds consistently passed inspection. Their attention to detail caught problems that might have escaped less careful eyes. The equal pay they received, 60 cents per hour, the same as male welders, was earned through demonstrated competence under conditions that would have defeated less determined workers. The scale of destroyer production at Bath Iron Works and other American yards represented more than industrial achievement. It was applied mathematics, translating steel and labor into strategic advantage. Each destroyer added to the fleet multiplied American naval power in ways that individual ship capabilities couldn't capture. Destroyers served as the backbone of task force operations. They screened aircraft carriers from submarine attack, their sonar and depth charges forming protective barriers around the most valuable assets in the fleet. They provided anti-aircraft defense, their 5-inch guns throwing up curtains of fire that disrupted kamikaze attacks and shot down bombers before they could release torpedoes. They fought surface actions, their speed and torpedo armament making them deadly threats to enemy cruisers and battleships. At the Battle off Samar on October 25, 1944, Fletcher-class destroyers Johnston and Howell charged Japanese battleships in suicidal attacks that bought time for escort carriers to escape. Both destroyers were sunk, but their sacrifice exemplified the aggressive spirit these ships enabled. They escorted convoys across submarine-infested oceans, their presence deterring U-boat attacks and hunting enemy submarines that threatened merchant shipping. They bombarded enemy positions during amphibious assaults, their accurate gunfire suppressing beach defenses and supporting troops advancing inland. They rescued downed pilots, pulled survivors from sinking ships, and maintained the human connection that made abstract strategy into personal commitment. Every mission demanded ships that could be trusted. Destroyers operated at the edge of their capabilities, pushing machinery to maximum output and hulls to structural limits. The welders at Bath Iron Works and other American yards built ships that could sustain that punishment month after month, year after year. The fact that so many Fletcher-class destroyers survived the war and continued service for decades afterward validated the quality built into them during frantic wartime construction. The human cost of destroyer warfare remained ever present in workers' minds. Bath Iron Works employees read casualty lists and learned which ships had been hit, damaged, or sunk. When USS Strong, a Fletcher-class destroyer built at Bath, was torpedoed and sunk off New Georgia on July 5, 1943, with heavy loss of life, workers mourned men they had never met, but whose survival had depended on their craftsmanship. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The pressure intensified as the war progressed. By 1944, American naval strategy demanded destroyer numbers that strained even the expanded shipbuilding capacity. The planned invasion of Japan would require hundreds of destroyers to screen the invasion fleet, suppress coastal defenses, and protect supply lines across thousands of miles of ocean. Bath Iron Works responded by pushing efficiency to new limits. The modular construction system that had seemed radical in 1942 became refined to near perfection by 1944. Assembly buildings operated with choreographed precision. Modules moved from station to station in carefully timed sequences. Welders worked in teams, each person responsible for specific joints, their movements coordinated to minimize interference and maximize output. The shipyard implemented innovations that would seem obvious in retrospect, but required vision to recognize during the chaos of wartime production. Indoor assembly protected workers from Maine's harsh winters, allowing work to continue regardless of weather. Overhead cranes positioned heavy components with precision that manual labor couldn't match. Prefabrication of subassemblies meant that even small components arrived at final assembly, fully tested and ready for installation. Quality control became embedded in every step of the process. Inspectors with X-ray equipment examined critical welds for internal defects, invisible to surface inspection. Magnetic particle testing revealed hairline cracks before they propagated into serious failures. Ultrasonic inspection verified that thick plate sections were fully fused. The inspection regime was more rigorous than peacetime practice, driven by awareness that shortcuts in quality control translated directly into combat casualties. The women welders understood this responsibility viscerally. They had brothers, husbands, friends serving in the Navy. The ships they built weren't abstract products but lifelines for people they cared about. This personal connection drove quality in ways that management directives never could. A welder who might have accepted marginal work on a commercial project refused to compromise on destroyer construction because she knew lives depended on every bead she placed. By summer 1944, the scope of Allied victory was becoming apparent. The Normandy invasion had succeeded. Soviet forces were pushing Germany back on the Eastern Front. In the Pacific, American forces advanced steadily toward Japan, supported by the most powerful fleet ever assembled. Destroyers built at Bath Iron Works and other American yards formed the steel backbone of that advance. The Battle of Leyte Gulf in October 1944 demonstrated the full power of American destroyer construction. The largest naval battle in history involved hundreds of warships across multiple engagements spanning thousands of square miles. American destroyers were everywhere screening carriers, engaging enemy surface forces, hunting submarines, rescuing survivors. Many of these ships had been launched within the previous 18 months. They performed flawlessly. Bath-built destroyers participated in every major engagement of the Philippine campaign. USS Nicholas, that early proof of concept from November 1942, was there. USS O'Bannon was there. USS Fletcher herself was there. They had survived 2 years of continuous combat operations and remained fully capable of aggressive action against a still dangerous enemy. The dedication of Bath Iron Works employees extended beyond simply building ships. When destroyers returned for repair or maintenance, yard workers attacked the job with same urgency that had characterized original construction. Battle damage was often extensive. Kamikaze hits created massive holes in superstructures. Shell penetrations required cutting out and replacing entire sections of hull. Torpedo damage demanded repairs that sometimes involved cutting ships in half and rebuilding entire compartments. Bath Iron Works developed expertise in battle damage repair that rivaled original construction capability. Workers who had built the ships understood their structure intimately. They knew where stresses concentrated and how to reinforce damaged areas. They could fabricate replacement sections that matched original specifications and install them in timeframes that astonished Navy officials accustomed to longer peacetime repair schedules. The USS Samuel B. Roberts, though not Bath-built, provided a dramatic example of American shipyard capability. When this destroyer escort struck a mine in the Persian Gulf in 1988, Bath Iron Works performed the repair by cutting out the damaged engine room and replacing it with a prefabricated module built in Bath. The technique, developed during World War II for emergency repairs, demonstrated that American shipbuilding excellence had permanent foundations. As 1945 progressed, the end of the war became inevitable. Germany surrendered in May. Japan, subjected to devastating air attacks and facing invasion, was clearly defeated, though still fighting. The destroyer program that had seemed impossibly ambitious in 1942 had succeeded beyond anyone's expectations. 175 Fletcher-class destroyers entered service. Bath Iron Works alone had built 30 of them, nearly 1/5 of the total class. When Allen M. Sumner-class destroyers entered production, an improved Fletcher design with 3 twin 5-inch gun mounts instead of 5 singles. Bath built 13 of those as well. The Gearing class, essentially a lengthened Sumner with greater fuel capacity, added more Bath-built destroyers to the fleet. The women who had transformed American shipbuilding capability faced uncertain futures as the war ended. Thousands of male veterans were returning home, expecting to reclaim the industrial jobs they had left. Many women were laid off or encouraged to return to domestic roles. Jean Croteau, who had mastered welding and helped build destroyers that won a war, left Bath Iron Works when peace came. The contributions of women welders were quickly overshadowed in popular memory. Post-war histories focused on admirals and battles, on strategic decisions and technological innovations. The unglamorous work of placing millions of welds in shipyard assembly buildings received little recognition. Women like Jean Croteau returned to private life, their wartime service known primarily to family and friends, but the physical evidence of their capability remained afloat for decades. Fletcher-class destroyers continued service into the 1970s. Many were transferred to Allied navies and operated into the 1990s. The last Fletcher, ex-USS John Rodgers, serving in the Mexican Navy as WWII, wasn't retired until July 2001, 59 years after the first Fletcher entered service. These ships survived typhoons, combat, and decades of demanding operations because they were built correctly. The welders who fused their hulls in 1942, 1943, and 1944 did their jobs so well that the ships outlasted the geopolitical circumstances that created them. The Cold War, conflicts in Korea and Vietnam, decades of peacetime patrols, Fletcher-class destroyers remained capable and reliable throughout. The technical legacy of wartime destroyer construction influenced American shipbuilding for generations. The modular construction methods pioneered under wartime urgency became standard practice. Modern warships are still built in sections, assembled from modules fabricated simultaneously and joined with precision that wartime welders would recognize. The welding procedures, developed through trial and experimentation during World War II, evolved into formal standards that govern naval construction today. American Welding Society codes incorporate lessons learned from both failures and successes. The Liberty ship crisis, which paralleled destroyer production, forced comprehensive research into steel metallurgy and welding practices. That knowledge, combined with empirical wisdom from skilled welders, created the foundation for modern structural welding codes. The integration of women into heavy industrial work, though temporary during the war, demonstrated capabilities that peacetime prejudice had denied. While most women were displaced from shipyard work after 1945, the precedent had been established. Future generations of women welders, engineers, and shipbuilders could point to World War II as proof that gender didn't limit industrial competence. Bath Iron Works continued building destroyers long after the war ended. The shipyard that had validated rapid construction during wartime returned to more measured peacetime schedules, but the expertise remained. Bath built guided missile frigates in the 1970s and 80s. The Arleigh Burke-class destroyers, entering service in the 1990s and still being built today, represent Bath's continuing mastery of destroyer construction. The phrase, "Bath built is best built," acquired deeper meaning through wartime experience. It wasn't just marketing, it was validated by ships that survived when they shouldn't have, that brought crews home against all odds, that performed reliably in conditions that exceeded design specifications. The women and men who built those ships earned that reputation through skill, dedication, and an understanding that their work directly affected whether American sailors lived or died. Jean Croteau passed away in 1987. Her obituary made no mention of her wartime service at Bath Iron Works. The destroyers she helped build had mostly been scrapped or transferred to other navies. The welding skills she mastered under pressure had gone unused for 4 decades. But somewhere in the Pacific, rusting hulks of Fletcher-class destroyers rested on the ocean floor, monuments to the brutal war that required their construction. And in archives and museums, preserved destroyers displayed the welds that thousands of women like Jean had placed. The USS Cassin Young, a Fletcher-class destroyer now preserved at the Charlestown Navy Yard in Boston, Massachusetts, allows visitors to walk through spaces that women welders built, the hull plates they fused, the joints they carefully prepared, the structures they reinforced all remain visible. Tourists who admire the ship's lines or marvel at its weaponry rarely consider the human hands that created it. But those hands were there, placing bead after bead, creating a warship from steel and skill and determination. The transformation of American destroyer production between 1941 and 1945 represented more than industrial achievement. It demonstrated that when necessity demanded capability, Americans could reimagine how complex work was done, who performed it, and what timescales were possible. The impossible became routine not through magic, but through practical innovation, hard work, and willingness to trust people who lacked traditional credentials but possessed competence. Bath Iron Works built 65 destroyers in 45 months. Jean Croteau and nearly 2,000 other women welders made that possible. They didn't build ships in 72 hours, no one did, despite the hyperbole that sometimes surrounded wartime production, but they did accomplish something equally remarkable. They proved that American industrial capacity, properly organized and motivated, could outproduce the rest of the world combined. The legacy endures in unexpected ways. Modern welders, male and female, trace professional lineage to World War II shipyards, where the profession was revolutionized under wartime pressure. Engineering schools teach cases about Bath Iron Works' modular construction methods. Naval historians study Fletcher-class destroyers as examples of successful warship design that balanced capability, producibility, and reliability. And occasionally, someone discovers a photograph. Women in welding leathers, hoods raised, standing beside destroyer hulls. Their faces show determination rather than triumph. They understood what they were building and why it mattered. They knew that somewhere across the Pacific, men they would never meet depended on the quality of their work. They delivered that quality, day after day, shift after shift, until the war was won and their contributions were forgotten by everyone except the sailors whose lives they had saved. The story of destroyer production during World War II is ultimately about ordinary people achieving extraordinary results under impossible pressure. It's about 18-year-old women learning to weld and becoming master craftsmen in months. It's about shipyards in river towns outproducing established naval arsenals. It's about steel transformed by skill into ships that changed history. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.